Hi everyone, so today's problem of the day is find the number of subsequences with equal GCD. And what is given in description, we are given an integer array nums. Your task is to find a number of pairs of non-empty subsequences, sequence 1 and sequence 2 of nums that satisfy the following condition. And what are the conditions? Sequences sequence 1 and sequence 2 are disjoint, meaning no index of nums is a common between them. The GCD of the element of sequence 1 is equal to the GCD of the element of sequence 2. Return the total number of such pairs. And we need to modulo the answer by 10 to the power 9 plus 7 because the answer can be very large. So we will be giving a nums array. If we will understand more with the help of this example, first example, so nums we have given 1, 2, 3, 4. So from this nums, we need to find the number of pairs of non-empty subsequence. So what we need to find, and there are few conditions, like if in my first I have two sequence 1 and sequence 2. Suppose if this one I am taking in first sequence, this one I can't take in the second sequence. It is written in the first condition that sequence and 1 and 2 are will be the disjoint. And the GCD should be equal. GCD is the greatest common divisor. So we will see 1 and 2. What is the greatest common divisor? What is the biggest divisor? Biggest number that can divide both of these numbers. So there is no common to it will be 1 for these. So if we will see about 20 and 30. So what is the GCD of these? Which is the greatest number that can divide both of these? So it will be 10. So the GCD for these numbers will be 10. Just letting people know if you don't know about what is GCD. So coming to our problem, so if one is coming to sequence 1, it can't come to sequence 2. Then second, if second, I can take it in sequence 1, 2, or I can leave it also. So suppose I leave it. Then third, I can take in sequence 1, else sequence 2. Suppose I am taking it sequence 2. Then 4, I am taking in sequence 2. So this is my valid answer. Why? Because the GCD for these, because the GCD for this is also 1, and GCD for this also is 1, which is equal GCD. So this is my one valid answer. So like that, if we will see in our solution, in our explanation, it is also given like this 1 and 2, 3. This is a valid pair. Then 1 in first sequence and the 2, 3, 4 in second sequence. This is also a valid pair because in all these cases, GCD for both the sequence will be 1 and it is equal. If it is, we are taking 1 here, then 3, 4, 1, 2, 3, 4, then in this 1 and 4, then other sequence 2, 3, 2, 3, then in this 2, 2, 3, 1, 4, 2, 3, 4, and 1. So all these are the valid number of sequences where the GCD for both the sequences are same. So if we'll come to the second example to understand it more clearly. So in second example, nums is given 10, 20, and 30. What will be the valid pair? Valid pair can be 10, 20, 30. This is my first sequence and this is my second sequence. This is a valid pair. Or else 20, 30, and 10. This is also my valid pair. Sequence 1 is this and sequence 2 is this. Why? Because the GCD for both of these will be 10. And for both these, it is also 10. So this is also a valid pair. For both of these also, it is 10, and which is equal. And this for that's why this is a valid pair. So these two are a valid pair. So we can return 2. So if we will understand how we can come to the solution. So what we can note here, like in num, we will be giving nums array, some nums array, and suppose it is like 2, 3, 4, 5, 6, something like this. So we are moving from starting to the ending. We need to find in this index. We need to put in. I have two sequence 1 and sequence 2. So I need to put this element in sequence 1 or sequence 2. If I'm putting it in sequence 1, then I can't put in sequence 2. Otherwise, I can skip also. So for every element we have the three options. So this is leading to the recursion. Why? Because every element will have the three options that I'm putting it in sequence 1, 2, or I can leave it. Then again I will move to the next index. Then I will move to the next index. So this is a recursion problem because there will be the repeated cases. So, but in recursion problem we will see. So how we can solve it. So to solve the recursion function, we know key since our constraints are this num's length and the size or the value of num size, this can go maximum till 200. So if we will go with the recursion, so we can see key time complexity can go to a higher number. So we need to optimize it, and we will be using DP to optimize dynamic programming. But to optimize it and use the dynamic programming, we need to see like we can understand it with the help of example as well. तो सबसे पहले we will be using recursion. Forget about this DP. We will come this after recursion. So in recursion, what I'm doing, I'm passing my nums array 0, 0, 0. What this 0, 0, 0 is denoting? This first is denoting my current GCD of sequence 1. This second, this J is denoting my GCD of sequence 2. And this 0 or this IDX is denoting my current index. So I will be using three conditions. First, what I will do, first I will not take my that current index value. I will not add my current index value to any of the sequence. So I will directly use the function nums I comma j comma index plus 1. I will not change my I and j because I am not using that value, current value. Then coming to if my this I is not equals to 0, I is not equals to 0, that means there is some GCD of sequence 1. If there is some GCD of sequence 1, then what we can do, we can calculate the GCD of nums of index, comma, nums of index, comma, this current GCD. With the help of this current GCD and nums of IDX, we can use the GCD function and we can calculate the our current GCD. Then if it is equals to 0, I, that means we don't have any current GCD for a sequence 1. Then we can directly say it is equals to nums of IDX. And then we can add this into our answer. Answer equals to answer plus, because this already we have calculated answer for if we are skipping that index, we are not including it in any sequence. Then second one, we are including it in sequence 1. So answer equals to answer plus, in place of I, we will pass G1 because G1 is my current GCD. J will be same, IDX plus 1 and N. Same for sequence 2 we will do. If my current sequence for GCD for sequence 2 is not equals to 0, then I will find the GCD using this current GCD and like previous GCD and nums of ITX. We will get the current GCD. Otherwise, if it is equals to 0, then I can say if okay, this is my first number, so it will be GCD will be equals to nums of ITX. And I will add this scenario also in my answer, and I will pass G2 in place of J because G2 will be my current GCD for second sequence, and I will do the index plus 1. And I will return at the end, I will return my answer. And what will be my base condition? If I will reach the end of the index, that is my index is greater than equals to n, then I will check if my I is not equals to 0, that means there is some element in sequence 1 and GCD of both sequence 1 and sequence 2 are equal, then I can return okay, this is my valid case to return 1. Otherwise, I can return 0. So this is basically the recursion. But coming to the DP, the DP what I am using, I am first initializing this 3D DP. Why I have used this 201, 201 and 201 here? Because my I is the maximum value of maximum is storing a GCD of sequence 1. So what can be the maximum possible value for I? It can go till the num psi value, maximum num psi value. And in our constraint, it is given that num psi can go maximum till 200. That's why we have declared I maximum value equals to 201 and J also 201. And index can also go till maximum 200. So the size for this is also 201. Now we are initializing using this memset function. We are initializing it with -1. After we will initialize it with -1, there are only 3 conditions to add DP. Adding DP to recursion is very easy. First is we need to initialize this DP. Then we need to first we need to declare the DP. Then we need to initialize the DP with -1. And third we need to check the condition, like if it is not equals to 1, -1, that means we already got the value of this I, J and I dx. So we can directly return the value. Otherwise, we will find all these using all these functions. And at the end, I will assign my DP of I, J, I dx equals to answer. So that next time if I will get these values, I can directly return it. And why I am using this I, J and I dx in my DP? Because if you will see in every function, my I, J and I dx there are 3 parameters that are changing in my function. That's why I've used 3D DP. I hope you are able to understand. And if you will see the time complexity, it will be equals to big of n into m square, where n is the number of element in nums array and m is the maximum possible value of nums of I. And space complexity, we will see space complexity will be equals to big of n into m square, same, because we have used 3D DP here. So I think you're able to understand this question. If you want the solution also, you can check out in the description. It will be there. If you have any query related to this solution, you can still reach out to me in the comment section with your queries. I will try my best to answer all your queries there. So thank you.